Welcome to Math 193 in class activity 2C, special angles. When a gear rotates 90 degrees counterclockwise, the tooth on the far right hand side of the gear moves up to the top of the gear. When it rotates 45 degrees, does the tooth on the far right move halfway up the top? Explain. I want you to think about this and try out with some answers, and we will discuss them. Your answers will vary, and one possible answer is that no. It moves more than halfway up. This is because when it starts moving from the far right, it is traveling more vertically than horizontally. So it rises more in the first 45 degrees than it does in the second 45 degrees. Objectives for the activity. In this activity, you will understand that certain special angle measures occur in math and science. And so you will be able to locate special angles on the unit circle, give measures of special angles, both in degrees and in radians, and then compute exact values for the sine and cosine of these special angles. In computer graphics and computer-aided design, points are defined or are specified by giving their coordinates in a grid. Often, designers like to draw equally spaced points lying on a circle. For example, to draw a blueprint for a gear with 8 teeth, one might need to find the coordinates of 8 points, like the points A, B, C, D, E, F, G, and H on the unit circle in the following figure. The coordinates of point B are cos t and sin t. For some angle t, what is t in radians? Think about this, try out some answers, and let's discuss your answers. Now, there are several ways to do this, but let's take one possible way to do it. The circumference of a circle is defined by 2 pi radius. In this case, we have a radius of 1, and we are considering the point B. And so the circumference becomes 2 pi times 1, which is 2 pi. And what this means is that when you go once round the circle, when you finish a complete revolution, you would have gone through an angle of 2 pi in radians, which is equivalent to 360 in degrees. Now, if you look at the point P, we have 1, 2, 3, 4, 5, 6, 7, 8. So this point B is just 1/8 of the total circumference. So it becomes 1/8 of 2 pi. And this is equal to pi on 4. So at this point where we have cos t and then sin t, t is equal to pi on 4 radians as below. Part B. Draw a line segment between points B and H. Between point B and H, and consider triangle BOH. Triangle BOH. Explain how you know that triangle BOH is a right triangle. What are the lengths of its legs, OB and OH? Think about this, pause the video, and try to come up with an answer. Now, part C says use the Pythagorean theorem to compute the length of segment BH. Compute this length. And so do this and then follow me with a possible answer. Now, what I have done is that I have drawn the line segment between point B and H, and that is this line. And this gives me the triangle BOH. BOH. And that is the triangle that I have extracted to this place. Now, explain how you know that triangle BOH is a right triangle? And the answer is, since BOH and AOH both have 45 measures, BOH is a right triangle. When you look at this, BOA, right? When you go this way, BOA, this is 45 degrees. Why is it 45? Because this is exactly at the midway as you move up from here, as we explained in the Ferris wheel. And then A, O, and H is also 45. So this is 45, that is 45. And when you add them, you get 90 degrees at B, O, H. And that is what I have here. Now the second part says that what are the lengths of OB and OH? OB is the radius, right? OB is the radius of the circle. Let me clean this up a little. OB is the radius of the circle, which is 1. And OH is also the radius of a circle, which is 1 unit circle. So we have 1 here. Now, using the Pythagorean theorem, we know that BH squared is equal to 1 squared plus 1 squared. And this gives us BH squared to be equal to 2. And so BH is equal to the square root of 2, as shown here. Now use the result of part C to compute sine pi on 4. Give an exact answer and a decimal approximation. And then also part E, draw a segment BD, right? Find its length and compute cosine of pi on 4. Pause the video, try out this, and let's meet to discuss your answer. Now, if you remember, we had BOH, sorry. And so this is our B, that is our O, that is our H. We had here to be root 2, there to be 1, and this is 1. This is pi on 4, and that is pi on 4. Because this is an isosceles triangle, and all the angles, this is 45 degrees, must add up to 180, and that is 90. So 90, 90, 180. Now the sine is defined as the opposite over the hypotenuse. So sine pi on 4 is equal to the opposite, which is 1, the hypotenuse, which is square root of 2. Now we rationalize this, and that gives us square root of 2 over 2. And when we evaluate this, you are getting 0.707 approximately. Now part E, draw a line segment BD, find its length, and compute cosine of pi on 4. This is BD. And so if we assume that this is our B, that is our O, and that is our D, OD is 1 unit 1, because the radius OB is unit 1. And just like before, this one is going to be square root of 2, because we are going to get BD squared to be equal to 1 squared, opposite squared, plus adjacent squared is equal to hypotenuse, right? The legs squared is hypotenuse. So BD is equal to the square root of 2. Now this is also an isosceles triangle. So this is going to be pi on 4, and that is going to be pi on 4. And cosine pi on 4 is defined as adjacent is pi on 4 cosine is defined as adjacent over hypotenuse, which is cos pi on 4, adjacent is 1, hypotenuse is root 2. And when we rationalize, as we did before, we are still going to get square root of 2 over 2 for cosine pi on 4. Use the result of question 2 to complete the following table. Each point BH corresponds to an angle AOB, AOH. For each point, T is a measure of the corresponding angle. Give exact answers. Pause the video, think about this, try out some solutions, and let's see what we can make out of it. Now let's look at the solution. The first one was done for you. And so let's go to the 45 degrees and pi on 4 degrees, which we already know. We have calculated that to be square root of 2 over 2 and the square root of 2 over 2 at this point at B. Now you must remember that this is x and that is y. And x is always equal to the cosine of t, and y is equal to the sine of t. 90 degrees has been computed, so let's move to D. At D, we are going to make use of our knowledge of reference angles. Now remember, we are measuring the angle from here to that point. And so what we need to do is to find the reference angle, which is the small angle made here between the terminal side and then the x-axis. And so if you notice, this is 45, 45, 45. This is 190. And then 190 plus 45 gives us 35. Or we have, this is pi on 4. That is pi on 4. That is pi on 4. And so we have 3 of pi on 4s. And that is what we are going to look at. And so the reference angle here is also pi on 4, 45 degrees. If you remember, this is reference angle. So at point D, we are going to look for our x and our y. Our x is just equal to the cosine of the reference angle, which is 45 degrees. But take into consideration of the fact that at that point, our x is going to be negative. This is negative x, and that is positive y. And because the x is negative, our x is going to be the negative of that cosine pi on 4, the reference angle. And pi on 4 is square root of 2 over 2. And we have negative that. And that is our answer. The sine t, remember our y is positive here. And so y becomes sine, and then the reference angle here is 45, pi on 4. And that is equal to square root of 2 over 2. And that is it. Now let me clean up this a little. When you go to the point E, the point E is lying on the horizontal. And look at it, our coordinates there are x is -1 and y is 0. It's lying exactly on the x-axis. And remember that x is equal to cosine t and y is equal to sine t. Now this whole angle is going to be equal to 180 degrees, or pi on 2. Or pi on 2 is 90 degrees. Now E is lying on the same line as A. If you remember, it means that the value for E is going to be like the value for A, except we are going to make some small changes. If you look here, the x coordinate here is going to be negative x. So we have negative x and -1 and 0. Now cosine of 0 was 1. And because this is negative, the cosine of 180 degrees is going to give us -1. Now the sine of 0 is 0. So the sine of 180 is going to give us 0. Now let's move to F. If you come to F, right, we are going to look for the reference angle. That is very important. Now, we are looking for all this angle. And the reference angle is this angle made with the x-axis that the terminal line is going to make with the x-axis, and that is T. Now, when you look at that region, you realize that Y falls in the negative region and X also falls in the negative region. And so our minus Y minus X is what we are going to get. And remember that we should have cos T for X and then sin T for Y. So if the coordinates are minus X and minus Y, the angle here is going to be 45 degrees. Then our cos T, our X is going to be minus cos T, and then our Y is equal to minus sin T. Now cos 45 is equal to square root of 2 over 2. So minus that is minus square root of 2 over 2. Sin 45 is square root of 2 over 2. So minus that is minus square root of 2 over 2. And that is what we have here and there. Now let me clean up a little and continue to G. If you look at the point G, this is lying exactly on the negative y-axis. All right. Now let's say that our x is going to be 0 and then our y is going to be -1. So this is x and y. Now we can use two methods to do this. Because this is lying exactly on the y-axis, there is no x coordinate because we have gotten to the maximum point. And we know that cosine of t is going to be equal to the adjacent, which is x, over the hypotenuse, which is the radius. And then our sine t is going to be equal to the opposite, which is y, this time is -y, over the hypotenuse, which is the radius, which is 1. So when we take the first one, because we have no x value here, everything is lying exactly on the y-axis, we say that cosine 270 degrees is going to be equal to 0 over 1 over -1, and that is 0, and that's what we get here. Or we see that sine 270, which is equal to 3 pi on 2, is equal to opposite, which was -1, over the hypotenuse, which is 1, and we are getting -1 here as our answer. What you can also do is that at that point, this is x is 0 and y is -1. At that point, this line is lying along the same point as the 90-degree line. And at 90 degrees, we had 0 and 1. And because here we are in the negative region, the sign turned into -1, as we can see, and then the cosine is 0, as we can see. Now we move to the point H, which is our last point. Still at H, we are going to have cos t and sin t, where this cos t is our x value and then sin t is our y value. Now look at this. We are looking for all these angles from here to there. All you want to do is to find a reference angle. The reference angle is this angle made with the x-axis there. So this t, this is what we are going to measure instead of measuring all that. So this is what we are going to measure. Now, if you want to construct something here, you will see that your y is going to be negative. right? Your y coordinate is going to be negative, and then your x coordinate is going to be positive. And the x stands for cos t, and so we look for cos 45, right, which is root 2 over 2, which we have already calculated. And then the sine t is negative, and since we are in the negative region, the sine 45 or sine 7 pi on 4 is going to be equal to negative root 2 over 2. Now, how do you get the 7 pi on 4? All you need to do is that you count the pi on 4s. Remember, we have divided this into 8 equal intervals. So this is 1, 2, 3, 4, 5, 6, 7. At this point, we have 7 pi on 4, right? And so 7 times pi on 4 gives us 7 pi on 4, right? Okay. And so that is that. Question 2 shows that a rotation of 45 degrees does not move the rightmost point on a circle halfway to the top. This question will help you find the angle measure that does. Consider the following diagram where points B and H are both at a distance of half unit from the horizontal axis. Draw a line segment between points B and H and consider triangle BOH. What are the lengths or the size of this triangle? What are the measures of its angles? I want you to pause this video, attempt this question, and let's see what you make of it. Now, based on the question, we draw BH, and that is our point A. That is our point A outside here, and that is O at the center. What I have done is that I have turned this down, round that way, so that we have our BH, or maybe our B here, and our H rather there. All right. And this is our A. Now, the question is, what are the angles, the measures of the angles? The lengths are 1 and 1, because these are the radii. OH is 1 and OB is 1. Now, we want to calculate the angles in the triangle. Now, to be able to do that, let's find the length of OA. All right. And what we want to do is that we know that from here to there is 1. From B to H is 1 unit. And so this is a half of it. And that is half of it. Since we are right at the middle, let's divide it into 2 equal parts. And so we can use this to find that angle. We can say that the cosine, if we call this angle T, cosine of T is equal to the adjacent over the hypotenuse, which is 1. So cosine of T is equal to 0.5. And T is the cos inverse or arc cos of 0.5. And if you look through your tables or use your calculator, you get this to be 60 degrees. Now, since this side is the same as that side, and this side is also 1, all these angles, when you sum them up, must give you 180. And what it means is that all this, we are talking about an equilateral triangle. And so this is also going to be 60. We don't have to calculate it. I was doing this to demonstrate something. And that is also going to be 60 degrees. And we have 60 degrees. So all the measures of the angles are 60, 60, 60. And the sides are 1 each. Part B, the coordinates of point B are cos t and sin t, cosine t and sin t for some angle measure t. Give the value of t in degrees and also in radians. Give exact answers. I want you to pause the video, consider this question, try your hands at it, and then let's take the answer together. Now, if you consider what we are looking for, we want to find the measure t, given that t, we want to find it in degrees and also in radians. If you consider the angle that we are dealing with, this is the angle that we are dealing with from the previous diagram. All that was 60. And so this line up to the point A divides this 60 into two equal parts. So this part of the angle is 30 degrees. 60 divided by 2 equals 30 degrees, right? 30 degrees, or it is equal to pi on 6 radians. You know that 180 degrees is equal to pi radians. And so 30 degrees just becomes 30 pi divided by 180, which is pi on 6 degrees. Now part C says that the diagram shows a close-up view of the top triangle in the diagram at the start of question 4. Determine the length of the segment OB and the value of sine pi on 6. Use these values in the Pythagorean theorem to compute cosine of pi on 6. You want to provide the answer as well as decimal approximation in exact value of decimals. Now this is what you want to do. You know that this length is the radius. This is where the radius intersects the circle, and because it is the unit circle, this is 1, right? So it is 1. The radius is 1. Now if you remember, this part of it is 1/2 from here, because from B to H was 1, so this is 1/2. That is what we have here. And so let's find the sine of pi on 6. The sine of pi on 6 is equal to the opposite, which is 1/2, divided by the hypotenuse, which is 1. And so sine pi on 6 is equal to 1/2, which is this. Now, you know that the cosine is the adjacent over the hypotenuse. This is the adjacent, and so we have to use the Pythagorean theorem to calculate it. And so let's see how we want to do this. Now, let's call this the x part, right? So the x squared plus 1/2 squared should be equal to 1 squared. So this gives us x to be equal to 1, this 1/2 squared is equal to 1/4. That gives us x squared to be equal to 3/4. And x is equal to the square root of 3/4, which is equal to square root of 3 over the square root of 2. And that is what I have here. Now the cosine of the angle, let me do that here for you. The cosine of the angle pi on 6 now becomes adjacent over hypotenuse, which is equal to 3/2 divided by 1. And anything divided by 1 is the same thing. So cosine of pi on 6 is equal to square root of 3/2. And when you divide square root of 3, which is 1.732 by 2, you get 0.866. All right. And so sine pi on 6 is 1/2, and cosine pi on 6 is going to give us root 3/2. 6 and 12-sided figures are common in design and architecture. Examples include the head of a hex board, a board with a hexagonal head, the spokes on some wheels, and the numbers on a clock. Therefore, it is important to be able to calculate the coordinates of 12 equally spaced points on a circle, such as in the following figure. Use your work from question 4 to complete the table, where T is a measure of the angle corresponding to each point. Give exact answers. I want you to think about this, try it out, and then let's see how we do it together. Now, in previous exercises, we did 0 degrees, and so I want to skip this. We have already done 30, so I want to skip that. We looked at 60, so I want to skip this. We have done 90, so I want to skip this. Now what I want to do is 120 at point E. You can see these are 30, 30, 30, 30, right? And so at point E, we have 1, 2, 3, 4 30s, right? And if 30 is pi on 6, then when you multiply this by 4, you will get the radian equivalence of the degree in that at that point. Now at this point, we are measuring this angle 120 degrees. And so what to do is that you want to find the reference angle here. And this reference angle is 60 degrees because all this angle is up to 180. And what we are cutting off here is 120 degrees. And 120 plus 60 will give us 180. Now, and so this 60 is just going to be like the answer for the 60 degree angle. But what is going to change are the signs of the x and y axis. Remember that here, the x and y values, coordinates are going to be cos t and sin t. Now, if you look at this line, you can see that the y component is positive and the x component is negative. And so what you want to do is that when you look at the 60 degrees, cos t is 1/2. So when you come to E, the cos t should be negative 1/2 because the x component there is negative. Now sine 60 is √3/2. And so sine 60 is going to be √3/2 there because the y component is positive. And so 120 degrees, these are the values for it. Now when you come to 150, from 120, f will give us 150. We still have positive y and negative x. So cos t is going to be negative and sin t is going to be positive. And this is 30 degrees. So when you look at the values for 30 degrees, which is pi on 6, we have negative √3/2 because the x is still negative, and positive 1/2 because the y is positive. 180 degrees we have done, and so I don't want to go through it again. 180 plus 30 will give us 210 at H. By similar reasoning, this you find the reference angle. Let me clean this up a little. So at that point, you find the reference angle at H, 210. This is all that 210. And this small angle is going to be 30 degrees. So that is what we are going to use. The y component is negative. The x component is negative. So cosine 30 is going to give us negative √3/2. And sine 30, which is 1/2, is going to give us minus 1/2. When we look at the I, it is the same thing. We are looking for all that the reference angle is this, which is 60 degrees. And the y component is going to be negative, and the x component is going to be negative. And so you have negative 1/2 for cos 60 and negative root 3/2 for sin 60. And it moves on. We have already done 170. And so this is 210. You will see that the y component is negative, but the x component is what? Is positive. And so this one will give you positive for cosine and negative for the sine. And you pick out your answer. This ends the end of 2C